Hi students, welcome back. We are going to talk about passive infrared sensor, that means PIR sensor, in this video. PIR sensor is used to detect the movement of heat sources. So what are heat sources? A human body, fire, or any heater, or even some of the non-living things which have heated elements or which transmit heat. So when these objects are moving, their movements are detected and converted into electrical signals by this sensor, and it is going to give very straightforward answer whether the movement is detected or not. This sensor is of a size of around 2 by 3 centimeters, and it is covered with a Fresnel lens on top. On the back side we have 3 pins, one for ground, one for VCC, and one for giving the output. So how does this sensor work? We have one pyroelectric sensor and a Fresnel lens. This sensor is going to detect any heat source movement in its detection area. So through the Fresnel lens, different small areas are created, and the source, if it is moving from one zone to another zone, then it is detected. So now we are going to see how do we connect this sensor and how to make a simple circuit using Tinkercad. So we have our circuit ready. Here is our PIR sensor, which is available in the Arduino library. We can drag and drop. There are 3 pins. One is for ground, one is for power, and one is our signal. So ground we have connected to Arduino ground, and 5 volt is coming to the power, and the signal is coming to digital pin number 2. I have connected one LED at pin number 12, and there is one voltmeter just to verify that what is the output voltage generated by this PIR sensor. Let us come to the coding part now. We are going to say a if-else statement. We are going to compare something. So let us drag and drop. Then we say input. Now our input is a digital input, so we are going to read the digital pin. It will fit when the white is highlighted, and it is connected at pin number 2. So this one we are going to have at pin number 2. It should be equal. That means if it is logic 1, then what should I do? In that case, I will say that set the pin number 12, which is LED, as high, and wait, keep it high for some seconds, maybe 3 seconds. Otherwise, if there is no movement detected, then set the pin number 12 as low. So that is the simple program that we have, and the corresponding text code is also fine. There are 2 pins, one is 2 and 12, one is input, one is output, and we are simply saying digital read pin number 2, and if it is 1, then digital write 12 as high, otherwise digital write 12 as low. So we are hiding the code and running the simulation now. So how do we work with this sensor? Well, when you click on the sensor, you can see here is an object. The XY positions are also mentioned, and if you move it, now this is the area in which the sensor is detecting the movement, which is in front of the Fresnel lens. So if you do any movement here, no detection is done. But as soon as you enter this area, detection is done, and this was on for 3 seconds. So within this area, if I move again, so you can see the voltage also changed. That means it got triggered and the LED was on. So if I make the changes again you can see both of them being triggered. Now if you are idle in front of the lens, your heat source is not making any movement, it will not trigger the sensor. Only when you move, then this sensor will be triggered. So that was very interesting sensor. We are going to use it for some applications also. In the next video, we are going to talk about one more very useful sensor called flex sensor. Thank you.